Guys, welcome back. So in this video I have condensed the paper of Google Lambda. I'll be attaching that paper for you if you want to go through the complete details of how Google Lambda was trained and all the terms of dialogue applications and all the terms used in the paper. But this is a short condensed form which gives you a summary of the paper. So Google was creating a language model that isn't new. In fact, Lambda joins the likes of Bird and Mum, a way for machines to better understand user intent. So Google has researched language-based model for variety of years with the hope of training a model that could essentially hold insightful and logical conversation on any topic. So far, Lambda appears to be the closest for Google to achieving this milestone. So, and one more thing I wanted to mention was as per the latest dataset when BARD was out, it was said the BARD, the current model that's out now, it was trained on 175 billion parameters. So, Lambda is basically an acronym for Language Model for Dialogue Application, was created to enable software to better engage in fluid and natural conversation. So Lambda is based on the same transformer architecture which we looked at in the previous video as other language models such as BERT, GPT-3, Go, Gophers, or many other models that are out there. However, due to its training, Lambda can understand nuanced questions and conversations covering several different topics. With other models, because of open-ended nature of conversation, you could end up speaking about something completely different despite initially focusing on a single topic. The behavior can easily confuse most of the conversational models and chatbots. And during Google I/O announcement, it was said that Lambda was built to overcome these limitations of the other model. So the demonstration proved how the model could naturally carry out a conversation on any random given topic despite the stream of loosely associated question on track, which was amazing to see. And the next one we will be looking at is how does Lambda work. So Lambda was built on Google open source neural network transformer, which is used for natural language understanding. So the model was used to find pattern in sentences, correlation between different words used in those sentences, and even to predict which word is likely to come next. So it does this by studying datasets consisting of dialogue rather than just individual words. While a conversational AI is similar to a chatbot software, there are some key differences between both of them. For example, chatbots are trained on limited specific datasets and can only carry on limited conversation based on data and exact questions it's trained on. Whereas Lambda is trained on multiple different datasets, it can have open-ended conversations. So during this training process, it picks up the nuances of open source dialogue and adopts. It can answer questions on different topics depending on the flow of the conversation. So, as I already told you, Lambda was trained on 1.5 trillion words and 175 billion parameters. Google explained Lambda has two separate training processes. One was pre-training and the other one was fine-tuning. And coming to pre-training, for pre-training stage, the team at Google created roughly 1.75 trillion words and multiple web documents. The dataset is tokenized. Tokenized in the sense turned into a string of characters to make sentences into roughly about 2.8 trillion tokens on which the model was initially trained. During pre-training, the model uses general and scalable parallelization to predict the next part of the conversation used on the previous tokens it has seen. And similarly, the next part is the fine tuning. So Lambda is trained on trained to perform generation and classification tasks during the fine-tuning phase. Essentially, the LaMDA generator, which predicts the next part of the dialogue, generates several relevant responses based on back and forth conversation. The LaMDA classifiers will then predict the safety and quality score of each possible response. Any response which is low safety is filtered out before the top scored response. Before the top scored response is selected to continue the conversation. The scores are based on safety, sensibility, specificity, and interesting percentages. So here is an example. So the goal is to ensure the most relevant, the most high quality, ultimately the safest responses is provided. So this image you see here is basically a score of safety, sensible, specific, and interesting, and it is from a Google blog. It is also mentioned in the paper I'll be sharing in this sharing below this lecture, so you can go through and read it in more detail. And similarly, the three main objectives of the model have been defined to guide the model training. These are quality, safety, and groundedness. So this is based on human rater dimensions, which is sensibleness, specificity, and interestingness. The quality score is used to ensure response makes sense in the context it is used, that it is specific to the question and is considered insightful enough to create a better dialogue. And the next one is safety. To ensure the model follows the standards of responsible AI, a set of safety objectives are used to capture and review the model's behavior. This ensures output does not provide unintended responses and avoids any bias. And the next one we are looking at is groundedness. So what is groundedness? It is defined as a percentage of response containing claims about the external world, which in other words is references to what it says. So this is used to ensure responses are factually as accurate as possible, allowing users to judge the validity of a response based on reliability of the source. And when it comes to evaluation, though an ongoing process of quantifying progress, responses from the pre-trained model, fine-tuned model, and human raters are being reviewed to evaluate responses against after mentioned quality, safety, and groundedness metrics. So far, they have been able to conclude that quality metrics improve with the number of parameters, safety improve with fine-tuning, groundedness improves as the model size increases. And whatever is mentioned is another image from the LaMDA paper which I have here. And I think ultimately that's it. And let me also bring you to the LaMDA paper I will attach, which I'll be attaching in this link. So it exactly has what we just read through, but in more detail. And if anyone's interested in this, they are free to go ahead and read it. I hope this helped. Thank you for joining.